1910 Teddy Roosevelt was in the White House. The Ford Model T had been on sale for less than 2 years. The American West was still being settled, literally homesteaded, and the climate record that would stand for the next 116 years was quietly being written into the data. That record was simple and brutal. The driest January through March the contiguous United States had ever measured. It held through 2 world wars, through the Dust Bowl, through every drought year that came after it, through all of it. 1910 stayed at the top. It doesn't anymore. Spring 2026 just erased it. The January through March period that just ended was the driest in 131 years of NOAA climate records, the entire span of systematic measurement. Not one of the driest. The driest. The record didn't squeak past 1910 by a rounding error. It broke it clean. To understand what that number means, you have to hold the 2 eras next to each other. In 1910, global carbon dioxide concentrations sat around 300 parts per million. Today they're past 420. The average American was burning wood and coal for heat. The atmospheric system that set that original record operated under fundamentally different conditions than the one that just broke it. A record that survived the entire industrial transformation of the planet. Every power plant, every tailpipe, every decade of warming, just fell. In a single quarter. What makes this harder to absorb is the geography. This isn't a regional drought that hit one unlucky corner of the map. The contiguous United States is nearly 3 million square miles. When a January through March precipitation record falls across that entire footprint, you're not talking about a weather event. You're talking about something that reorganized the whole continental atmosphere for 3 straight months. And here's the thing that keeps coming up the more you look at the data. 1910 didn't fall because conditions finally got a little worse than they were back then. It fell because 3 completely independent ways of measuring drought, 3 separate methodologies that have no reason to agree unless the drought is genuinely extreme, all set their own historic records at the same time, separately, simultaneously. That convergence is next. Start with precipitation, the most straightforward of the 3. NOAA tracks rainfall and snowfall totals across the contiguous United States going back to 1895. January through March of 2026 came in as the driest such period in that entire 131-year record. Not the second driest, not close. The record gone. But precipitation alone is a blunt instrument. It tells you what fell from the sky. It says nothing about what the land could actually do with it, how saturated the soil was going in, how fast moisture evaporated back out, what the cumulative deficit looked like after months of running dry. That's where the second metric comes in. The Palmer Drought Severity Index, PDSI, was designed specifically to capture that fuller picture. It weighs precipitation against temperature, evaporation, and soil moisture to produce a single number describing how stressed the land actually is. It's been the standard tool in drought research for decades, and it set its own historic record this spring, not mirroring the precipitation record independently. The PDSI calculates stress through a different equation, drawing on different inputs, and it arrived at the same verdict: conditions not seen in the modern instrument era. Then there's the US Drought Monitor, the third method, and the one most people actually see. It's a weekly map, produced by a collaboration between NOAA, the USDA, and the University of Nebraska-Lincoln, that synthesizes dozens of data streams and then layers in expert judgment from local observers on the ground. It's not an algorithm running on remote sensing alone. Real people with boots in real places are part of the signal. And the coverage percentage it recorded this spring, the share of the contiguous U.S. classified in drought, hit a historic high. 3 methodologies, 3 different designs, 3 independent records, all broken in the same window. That's the thing about convergence. Any one of these measures, alone, can be questioned. Instruments drift. Models have assumptions. Coverage maps have edge cases. But when you build a case from 3 separate foundations, and all 3 load-bearing walls crack at once, the argument stops being about methodology. The drought isn't an artifact of how you're measuring it. It's real, it's deep, and it's spread across the land in a way that all 3 systems, independently, have never seen before. All 3 systems measured the same catastrophe from different angles. Now look at what that catastrophe actually did to the ground. April 1st is a date hydrologists treat like a reckoning. It's the traditional peak of the snowpack, the moment when winter's accumulated precipitation sits locked in mountain snowfields at its maximum depth before spring melt begins. Water managers across the West use April 1st snowpack measurements to forecast how much water will flow into rivers, reservoirs, and aquifers through the dry summer months. It is, functionally, the West's water balance sheet for the year. You read it on April 1st and you know roughly what you have to work with until the rains return. This April 1st, 8 western states set record-low snowpack simultaneously. Not one state having a bad year. Not a regional cluster with a few outliers. 8 states, measured independently, each recording the lowest snowpack depth ever observed on that date. California, Nevada, Utah, Colorado, Arizona, New Mexico, Oregon, Idaho. The records fell across the full sweep of the Mountain West, from the Cascades to the Rockies, to the Sierra Nevada, in the same window. Here's what that number actually means. Snowpack is a reservoir. It doesn't look like one, it's not behind a dam, there's no gauge you can read from a helicopter, but that's exactly what it is. Mountain snowfields store water through the winter, and release it slowly through the spring and summer as temperatures rise, feeding the rivers and streams that fill the actual reservoirs downstream. When the snowpack is low, the summer release is low. Rivers run thin. Reservoir levels that were already stressed by years of drought don't recover. Groundwater that was already being drawn down faster than it recharges gets drawn down further. The 8 states that set those records are home to roughly 60 million people. They are also the agricultural core of the country, the Central Valley, the Colorado River Basin, the Columbia Plateau. The crops planted this spring were planted against a water budget that, on April 1st, was already in deficit before the growing season began. And the snowpack doesn't come back. You can't hold a drought summit in May and refill the mountains. Whatever was missing from those slopes on April 1st is simply gone from the summer water supply. The deficit is locked in. That locked-in deficit doesn't look the same everywhere. In the West, it's a slow arithmetic. Rivers running low by July, crops stressed by August, reservoirs drawing down to pale white bathtub rings. But in Florida, the drought wore a different face entirely. At the April peak, 98.99% of Florida was in drought. Not experiencing dry conditions, not abnormally dry. In drought, the category that means wells dropping, topsoil cracking, fires moving through scrubland that should be too wet to burn. Think about what it takes to get a number like that. Florida is a peninsula surrounded on 3 sides by warm water. It gets more annual rainfall than most of the continental United States. Its aquifer system is one of the most productive in the world. And in the spring of 2026, you could drive from Jacksonville to Key West. Every county, every watershed, every one of the state's 21 million people, and be inside a drought the entire time. The 0.1% that wasn't, a handful of pixels on a map. That near total coverage is what makes Florida the human-scale version of this story. The western snowpack numbers are devastating in their consequences, but they're abstract. Mountain elevations, acre feet, reservoir percentages. Florida is lawns that stopped growing and then started dying. It's citrus groves, where the fruit set wrong because the trees were stressed through the dry season. It's wildfires moving through the Everglades in March, when standing water is supposed to be the natural fire break. 98.99% isn't a drought statistic. It's a statement about coverage so complete that the exceptions prove the rule. When a state that sits in the subtropics surrounded by ocean runs almost entirely dry, that's not a regional anomaly. That's a signal about the scale of what is happening across the whole country. And the signal was already strange before you factor in the one driver everyone was watching, the one that, by the spring of 2026, still hadn't fully arrived. The one driver everyone was watching, the ghost that still hadn't fully arrived. El Niño is the warm phase of a climate cycle driven by sea surface temperatures in the central and eastern Pacific. When those waters heat up enough, they redirect the jet stream, reshape storm tracks, and amplify drought across huge swaths of North America. Forecasters had been tracking a developing super El Niño heading into 2026, one of the stronger events on record. The models were clear, the conditions were building, and the expectation, almost universally shared, was that if the drought was already bad by early spring, El Niño was going to make it catastrophic. Here is the inversion that should stop you cold. The record, the driest January through March in 131 years, fell before the super El Niño fully arrived. The worst driver in the forecast hadn't even shown up yet. Think about what that means structurally. You have a record-shattering drought, shattered across 3 independent metrics simultaneously. 8 states with record-low snowpack, Florida almost completely dry, and the amplifier everyone was building their worst-case scenarios around was still in the warm-up, still offshore, still developing. It's the equivalent of a city flooding before the storm makes landfall. The damage you can see is the pre-storm damage, and the storm is still coming. Climate scientists have a name for what happens when a strong El Niño event arrives on top of an already depleted system. Soils already desiccated, reservoirs already drawn down, snowpack already absent. The term is compounding. The drought doesn't just continue, it deepens faster than models trained on wetter baselines can reliably predict, because those models were calibrated on systems that had more water in them to begin with. The 1910 record, the one that just got broken, was set inside a climate where the baseline was different. Cooler average temperatures, more moisture in the soil between dry spells, a western snowpack that recovered reliably each winter. That system had buffers, slack in it. A bad year was a bad year. It didn't necessarily hollow out the year after. The 2026 drought broke that record in a climate with far less slack. The buffers are thinner, the recovery cycles are shorter, and the El Niño that everyone expected to be the defining driver of this drought, the headline cause, the thing to point at, hadn't even delivered its full weight when the record gave way. So the question that follows isn't whether the drought will get worse. The conditions for that are already set. The question is what happens to the systems that depend on water when the amplifier finally arrives. Agriculture, reservoirs, the fire season sitting behind the snowpack that wasn't there. Agriculture moves first, because it has no buffer left to spend. Western farmers entered this spring with already depleted aquifer levels and surface water allocations cut to fractions. And now the snowpack that normally feeds those allocations through June and July simply isn't there. You can't borrow water from mountains that stored none. What that means practically: fields that would have been planted are being fallowed. Decisions made in April about what to irrigate will determine what reaches a grocery shelf in September, and those decisions are being made right now under the worst supply conditions in a century. Reservoirs are the second domino. They were designed as buffers. You overfill them in wet years and draw them down through dry ones. That model works when wet years and dry years alternate on a predictable human timescale. It doesn't work when you stack dry years alternate on a predictable human timescale. It doesn't work when you stack dry years alternate on a predictable human timescale. It doesn't work when you stack dry years alternate on a predictable human timescale. Several major Western reservoirs entered this spring at levels that, a decade ago, would have triggered emergency declarations on their own. They're not getting a snowmelt recharge. The math of their drawdown curves points somewhere uncomfortable before fall. Then there's fire. Wildfire needs three things: dry fuel, low humidity, and wind. The vanished snowpack didn't just reduce water supply, it left the soil and vegetation across 8 states drier, earlier in the season, than any April on record. Fire season in the West has been lengthening for decades. This year it may not have a start date in the traditional sense, because the conditions that used to define late summer fire risk arrived in spring. The buffer between a spark and a catastrophe is thinner than it has been in the lifetime of the satellite data. And here is the part that doesn't ease when the rain eventually returns. The feedback loop is already locked in. Dry soil absorbs less water. Less vegetation means less transpiration, which reduces local humidity, which accelerates further drying. Depleted aquifers don't refill on a seasonal timeline, they refill on a geological one. A reservoir that drops to 20% capacity in 2026 doesn't return to full by 2027 even in a wet year, because the infrastructure of recovery, the snowpack, the groundwater, the soil moisture has to rebuild in sequence. Every system that fails this year raises the floor of vulnerability for the next dry year. And the El Niño that held back its full force, it's still developing. That El Niño is the reminder that 2026 is not the bottom. It is a floor that keeps moving. Which brings us back to 1910, because that record didn't fall by accident, and it didn't fall to a random bad year. It fell to a specific kind of year, one produced by a climate that has been, by measurable degree, drying the American West and destabilizing the moisture patterns across the entire contiguous United States for decades. The record that stood for 116 years was set in a climate that no longer exists. In 1910, the United States was a country of roughly 92 million people. The West was sparsely settled. The Colorado River had never been dammed. The Ogallala Aquifer had barely been touched. There was no satellite data, no Drought Monitor, no Palmer Index, just rain gauges and the memory of farmers who noticed the grass was brown. The record set that year was recorded in a world that had enormous reserves, groundwater nobody had drawn down, soil that had not been stripped of its moisture-holding capacity across generations, forests that had not been thinned by a century of fire suppression and then shocked by warming. When drought hit in 1910, it hit a system with slack in it. The drought of 2026 hit a system running on fumes. Every buffer that existed in 1910 is smaller now. Some by a little, some by half, some essentially gone. The record didn't just get broken, it got broken by a drought that arrived into a landscape already weakened, already depleted, already past the margin where a single wet year resets the clock. A record born in one climate era just died in another. That sentence is precise. The climate in which the 1910 record was set, its average temperatures, its typical precipitation patterns, its baseline snowpack, is not the climate of 2026. We are measuring a new era with instruments calibrated on the old one, and what they're showing us is that the extremes of the past are now the baselines of the present. 1910 to 2026 is 116 years. In that span, the United States built the Hoover Dam, depleted the largest freshwater aquifer in the world, tripled its population, and moved tens of millions of people into the driest parts of the continent. The infrastructure of American life was engineered for a water supply that is no longer guaranteed. The record that just fell was the last formal confirmation of something the data has been saying for years. The long dry isn't coming. It's here. And it didn't wait for the worst to arrive before it started breaking things.